Hey guys, my name is Jason with Mount Baker Mining and Metals, and today I wanted to go over the soda iron nail smelting method. And this uses iron to reduce the materials in a concentrate so you don't need to roast them. And there's a lot of benefits to that. So in today's video, we're going to go over the execution, why I'm so excited about this method and trying to perfect it, and show you guys how to do it. So let's get started. Okay, so our first step here is we're going to mix up our material. We're going to start with some sulfide concentrates off our shaker table. And I'm going to measure out 130 grams. There's the material we're going to be smelting. I'm going to put this in another container so we can mix it all up. The components we're going to be using are anhydrous borax, lye, and silica sand. And so we're going to go through those, and I'm going to talk about why we're going to use each one. First, we're going to use our anhydrous borax. So I'm going to take this. I'm going to weigh out 100 grams. So there's our borax. We're going to mix that in with our sulfides. We're going to take some lye here. This is very, very basic. You want to make sure you're wearing gloves and goggles, protective glasses when you do it. We're going to add 120 grams of lye, and this will make our material basic, which will help us absorb the iron sulfide that we're going to create. And then the last one is silica sand. And for our silica sand, we're going to do 40 grams. And if your material already has a bunch of silica in it, you can kind of estimate and ratio the silica down. We're just adding this for the silica content. A lid. Here's our jug of material. We're going to mix it all up, make it so it's all nice and uniform. And then we're going to add it into our crucible here. This is a number 5 crucible. It comes up about halfway. You don't want to add so much that it comes up right to the brim, because this stuff, as it heats, it's going to expand and bubble and boil a little bit. So you want to make sure you have some room for it to expand, and then it'll contract way down once it's all molten. So we'll take this and we'll put it in our furnace, and we'll get it heating up and turned molten. We're going to add an iron bar to it to reduce any base metals that are in here. And all the sulfides are going to end up being converted to iron sulfide, FeS, which hopefully most will be absorbed by our slag. That's why we added all of our lye. But we got our first one here. Let's get this going in the furnace and see what we come out with. Oh, and one more thing. I'm going to add 50 grams of lead to this as well as our collector metal. So that'll be our collector metal at the bottom. Okay, here's our crucible. It's in our furnace here. This is just a wrap of KO wool. And I've got a video that I just made showing how to make this furnace. So you guys can check that out. But it's powered by propane, and it gets well over 2,200 degrees Fahrenheit. So should be plenty hot enough for what we're doing. All right, we're on our second smelt here, and I wanted to show you guys this crucible actually failed right as I was taking it out of the furnace. So I got all my slag in there and all my metal, but you can see the cracks, and it came leaking out right there on the bottom. And so that tells me that this is it's too basic, and it's eating away our crucible. And what I've heard is most of the times when your crucible gets eaten up, you don't have enough silica in your mix, because it'll rob silica from the crucible and eat it up pretty fast. And that's one of the things you don't want. I wanted to take just a second here and walk through the 5 different smelt samples I'm going to be doing. And I'm trying to find this universal recipe for smelting. The first one here is pretty much pure sulfides. There's some iron pyrite, there's some chalcopyrite, and there's a little bit of oxides in there. So that's our first one. Our second one is pretty much 100% pure iron pyrite, fool's gold. So we'll give that a shot. Our third one is mostly oxides, actually, and so it's black sand. This would be kind of considered like a sluice concentrate or a plaster concentrate. There's not many sulfides in there. It's mostly oxidized. This is pretty much pure quartz tailings. This has been run through the system. This is the number 4 off our shaker table. So that should be mostly quartz with very little sulfides or oxides in it. And then this is just some head ore. So it's got silica in it, some sulfides, not many oxides. And so we're going to run all 5 of these in that order that I went through, and see if we can get a good recovery out of all of these. Our goal is first is no matte. Second is high percentage of gold recovery. Third is going to be keeping the crucible in good shape. And then fourth is going to be a nice quiet smell that's not boiling, it's not expanding, it's not filling up and flooding the furnace with a bunch of junk and screwing up our furnace lining. So those are kind of our goals, and the 5 samples we're going to be running today. I wanted to take a second here and show you guys, I've kind of improved my cupelling method here. And this is a little electric furnace. And it's got the coils in there. And this is where I'm starting to do my cupel. So when I get the lead button, I put it in this cupel, which absorbs the lead oxide as we heat it up. And in the past, I've done this in my gas furnace, but it's really, really hard to control the temperature and get a nice even heat. Whereas with this one, when I turn it on, I can control the temperature right down to the degree. And for the oxygen, I can just crack the door a little bit and let the air blow through. It oxidizes the lead. I can control the temperature really nice, and we get a really nice precious metal bead in the bottom of that cupel when it's all said and done. So I'll show you the process, but wanted to walk you through my new improved method here. Here's our first cupel in our little electric furnace. And I moved it over so if I need to, I can put another one, and actually I can probably run 4 or 5 in here at the same time. But this is a pretty nice little furnace. You click it on, you can set your temperature. It remembers my temperature from last time, so 1775 is what we're gonna do. I'm gonna close the door and latch it. and let it heat all the way up. And then I will crack the door and let some oxygen in once it heats up. So we'll check back on this in a couple minutes and see how it's going. All right, we're a little over 1500 degrees. And it's been about 6 or 8 minutes. It hasn't been very long. So let's see if I can unclamp this thing with one hand. So our lead's molten, and the black stuff on top is either a little bit of that slag or it's lead oxide. And that's the temperature inside the furnace is 1500. That crucible or that cupel probably isn't up to temperature yet. So we'll check back on it in a couple more minutes and see if we can see that lead starting to oxidize and drive into the cupel. Here's all our cupels for the day. And we'll start over here. This is in order of what we smelted. So this is the bead from the sulfides and oxides. This is the bead of pure sulfides. This is the bead of mostly oxides. This one, which is still hot, is some quartz tailings. This one is some head ore. That one is some pure iron pyrite again. And this one is some matte from a previous smelt. And you can see that all the beads are different sizes, which is to be expected because they're not all the same grade. And this one is clearly the best. That's actually a pretty good sized bead from 120 grams of material. But you can see the cupelling process here. And what it does for you, it ends up all the oxides, the base metal oxides, are absorbed into the cupel, and you're left with only the precious metals. So you have gold, silver, and any PGM, platinum group metals are going to be left in your bead because all the other metals, the base metals, copper, lead, zinc, iron, all oxidize in the furnace and get absorbed into our cupels. So I hope you guys enjoyed the video today. One more thing before I sign off here is, we're dealing with a lot of pretty nasty stuff. You got lye, which is really caustic. It'll start dissolving your skin. If you get it in your eyes, it'll blind you. We're dealing with lead fumes, lead oxide, the sulfur dioxide coming off the furnace. When you breathe that in, it gets in your lungs and mixes with the water and turns into sulfuric acid. So just if you're going to do any of these experiments, just make sure you do, follow the safety guidelines. Wear a respirator. I use a P100, which is recommended for dust and lead in particular. Glasses, gloves, all the stuff to keep you safe. So just wanted to put that out there for you. I know you YouTubers are concerned for your safety and mine as well. So that's my little safety talk for the day. But again, I hope you guys enjoyed the video. Hope you learned something. Please let us know if you have any questions or comments. All of that information is in the description below. So thanks for watching, and we'll see you on the next one.